All right, number 3. It says the public U.S. debt in May 2017 was 1.89 times 10 to the 13th. What was the average U.S. public debt per American if the population in 2017 was 4.25 times 10 to the 8th people? Round your answer to the nearest dollar. So by it saying rounding your answer to the nearest dollar, that should let you know that your answer will not be in scientific notation. All right? Your answer will not be in scientific notation. So the first thing we're going to do is, if it says per means division. So what I'm going to do is I'm going to take 1.89 times 10 to the 13th, and I'm going to divide that by 4.25 times 10 to the 8th. All right? And now the next thing that I'm going to do is I'm going to divide this problem up into 2 problems. All right? So just like how I did on the last one, I need to split this up. So I'm going to say 1.89 divided by 4.25 times 10 to the third. Oops, sorry, y'all. Times 10 to the 13th divided by 10 to the 8th. All right, now I'm just going to remind you guys that our answer will not be in scientific notation. So remember that, but we can start off with scientific notation to do this problem. So in the calculator, I'm going to put 1.89 divided by 4.25, and we get this long decimal answer of 4.44470, and I'm going to stop right there. All right? And then the next thing we got to do is times. Our base stays the same at 10 and 13. 13 subtract 8 is 5. The reason why I did 13 subtract 8 is because we know that with our exponents, whenever we are dividing, that we need to subtract the exponents. So with that being said, that is going to bring me to 10 to the 5th. And since our answer cannot be in scientific notation, I'm just going to move that decimal 5 places over. So I'm going to change the color so you guys can visually see that. 1, 2, 3, 4, 5. So the decimal goes right there. So I have $44,470 per American. If I'm not mistaken, that is the answer. That is number 1. Number 4. It says I'm sorry, let me go down. Number 4, it says the population of Russia is estimated at 5.1 times 10 to the 8th, and the world's population is estimated at 9.5 times 10 to the 9th. About how many times greater is the population of the world? About how many times greater is the population of the world than the population of Russia? This is going back to number 2. With that, how many times greater? So what I'm going to do, I'm just going to divide. All right, what I'm going to do is I'm going to take 9.5 times 10 to the 9th, and I'm going to divide that by 5.1 times 10 to the 8th. And once again, I'm going to break this up. So I got 9.5 at the top, 5.1 at the bottom, times 10 to the 9th divided by 10 to the 8th. So I'm going to take 9.5 divided by 5.1, and I get this answer of 1.862 times 10. And we know that whenever we are dividing exponents, we subtract. 9 minus 8 is 1, so I got 10 to the 1. which means if we look at our answers, they don't want an answer in scientific notation. So I have to move that decimal place over to the right, 1, and I have 18. And if I'm not mistaken, there is an answer on there that says 18. Number 5. It says, what is a solution of x in this equation? So if I got 4x times 6 to the 8th is equal to 632. All right, we need to remember our law of exponents. The law of exponents says that whenever we are multiplying, that we need to add the exponents. So we could just create a little equation. Since all of our bases are the same at 6, I could just create an equation and say that 4x plus, I did plus because like I said, the law of exponents says that whenever we are multiplying, that we need to add the exponents. So I got 4x plus 8 is equal to 32. This goes back to our basic knowledge of two-step equations. The first thing that I need to do is isolate x by itself. In order to isolate x by itself, I need to subtract 8 from both sides. When I subtract 8 from both sides, all right, this cancels out. 8 minus 8 is 0, so I'm just left with 4x is equal to 32 minus 8 is 24. And then I need to divide 4 from both sides. The reason why I am dividing 4 from both sides is because the relationship between 4 and x is multiplication. In order to do the inverse operation of multiplication, you need to divide. So I divide 4 by both sides, and I'm left with x is equal to 6. If I'm not mistaken, that is one of the answers. That is the second one. All right, number 6. It says a complete orbit around the sun for Saturn is approximately 7.9 times 10 to the 9th miles and approximately takes 5 times 10 Earth years. If Saturn travels at a fairly consistent speed, about how far does Saturn travel in 1 year's Earth orbit? All right, Mr. Beavers, so what are we going to do with this problem? All right, the first thing that I'm going to do is I'm going to write down my the two scientific notation problems that they give you. All right, so the first one we have is 7.9 times 10 to the 9th, and we're going to divide that by 5 times 10 to the first. As you can look, most of these problems are dividing scientific notation. So if you know how to divide scientific notation, you're going to be just okay on this test. So the same process. This is now our third problem that we're dividing scientific notation, and I have done it the exact same way every single time. So the first step that I'm going to do is I'm going to split apart the two numbers. So I'm going to take 7.9 and I'm going to divide by 5 times 10 to the 9th, and I'm going to divide that by 10 to the first. When I take 7.9 and if 7.9 divided by 5, I get 1.58 times, and now we know our base is going to be 10, and now we just got to take 9 minus 1. 9 minus 1 is 8. And that's our answer because it's already in scientific notation. It looks like that's the first one. All right, number 7. It says, which one of these are the largest? All right, now, anything that is negative is going to be a very small number. Anything that is raised to the negative exponent is going to be a very small number. So we can already eliminate the second one because we know that the first one has a positive exponent. So since the first one has a positive exponent, then it's already larger than the second one. And also we know that the third one has all the zeros behind the first number, so we know that that's a larger number than the second one. So now we're just down to the first option and our third option. What I want you to look at is, I want you to go to the third option and I want you to count how many zeros are there. So when we count how many zeros are there, we have 1, 2, 3, 4, 5. All right, so in 100,000, we have 5 zeros. All right, so we're taking that place value out. But when we look at this, when we go to our first option, there is 7 place values. 7 place values is larger. I'm sorry. 7, you have 6 place values. 7 place values is larger than 6 place values. So without even doing any type of math, I can already know that 7 is larger than 6. So my answer is the first one. My answer is the first one because it's larger. Number 8, it says, which one of the following represents 8.67 times 10 to the 7th in standard form? All right, so remember, standard form is when you write the number out of scientific notation. Right now, this problem is in scientific notation. So if I was to write 8.67 times 10 to the 7th, this is scientific notation form. Standard form is taking that decimal, and moving it 7 times. All right, so what I'm going to do, but if we look at our options, there's only one option that makes sense. We don't even have to do it because this is a positive exponent, right? A positive exponent, and it's to the 7th power. If it's a positive exponent to the 7th power, then that means my zeros are going to be to the right of the decimal. The two options that we have zeros that are in front of the 8. That is not true because this 7 is a positive 7. So we know that our answer is the second one. Number 9, it says, which one of the following best represents that number in scientific notation? So number 9, I'm just going to write it out. So I got 0. How many zeros are there? 3. 1, 2, 3. 7, 0, 9, 8, 1. All right, the rule for scientific notation says that we must put the 0 after the first number. All right, because scientific notation says that our leading digit has to be between 1 and 10. So when we put the decimal after our first number, the first number we see is 7. So we have to count from here, from this decimal all the way over to this decimal. So I'm going to rewrite this with the decimal being right there. So I got 7.0981 times 10. And now I just need to count. So I have 1, 2, 3, 4. I counted the 7 because the decimal went behind the 7. So I got 4 places, right? And now, the zeros are in front of the 7. And so since the zeros are in front of the 7, I know that that answer will be negative 4. So when I look at my answers, I should see one. The first thing that I look for is I look for the negative 4. So I look for the negative 4. Oh, I found negative 4. It's the second one. And then I make sure that my numbers are right. So I see the 7. I see the decimal, I see the 0, I see the 9, I see the 8, I see the 1. It's the second one. Number 10, it says perform the operation, enter your answer in scientific notation. So right now all we're doing is just subtracting. So we got 9 times 10 to the 5th, subtract 5.6 times 10 to the 5th. The good news about subtracting with scientific notation, whenever we subtract or add in scientific notation, we must have the same base and we also must have our exponents to the same power. Currently, our exponents is to the same power. It's to the same power of 5 and our base is the same at 10. All right, so if our base is the same at 10, and our exponent is the same, then we can subtract this. So I'm just going to say right now we have 9. So we have 9 subtract 5.6. Make sure you line up your decimals correctly. Whenever you take 9, subtract 5.6, that's 9. 5.6. So now, can I take 0 from 6? I cannot. I can borrow. That becomes an 8. This becomes a 10. 10 minus 6 is 4. 8 minus 5 is 3. Keep that decimal right there. So I got 3.4 times 10 to the 5th. If you had entered that into your calculator, that's fine. But I just wanted to show you guys how to do it using, if you didn't want to enter it into your calculator. And you guys saw how I make sure that I lined up my decimal. So it looks like that is our last answer. It's the last one. Number 11. It says, what value of n makes the following equation true? So it's the same thing. We got 4 to the 5th times 4 to the x is equal to 4 to the 14th. Our bases are the same. Since our bases are the same, I can just subtract this. I'm sorry, not subtract this. Since our bases are the same, I can just rewrite this problem. Whenever we're multiplying and our bases are the same, we add the exponents. So I have 5 plus x is equal to 14. I need to subtract 5 from both sides. X is equal to 14 minus 5 is 9. X is equal to 9. I think that's one of our options. Actually, yes, it is. It's the first one. 12. It says, calculate the quotient below and give your answer in scientific notation. If I'm not mistaken, this is our 5th division problem. What I'm going to do, I'm going to make sure that I line them up. So I got 5.9 divided by 5 times 10 to the 8th divided by 10 to the 4th. In my calculator, I'm going to put 5.9 divide by 5, and I'm going to get 1.18 times. Whenever we are dividing exponents, all right, we subtract. So 8 minus 4 is 4, so I got 10 to the 4th. And it's already in scientific notation because the decimal is after the first one. So when I look at my answers, it looks like that is the third one. All right. Number 13. It says, which value is closest to 6 times 10 to the 6 plus 2 times 10 to the 4th. All right, and it says which value is closest. So look, this is what we need to do. If we're adding exponents, remember what I said, our base has to be the same. Our bases are the same, but also our exponents has to be the same. So if our base and our exponents has to be the same, that means that I have to change that 4 to a 6. And when I change that 4 to the 6, then I can look at my two answers. The only one that can be closest to is the first one, because there's no way that I'm going to go down to the 10 to the 4th if I'm adding. That means my number is getting bigger, not smaller. So without even doing any type of math, just by logic, I know that my answer is the first one because my answer needs to get switched to the to the exponent of 6. So I didn't do no math in that problem. I just knew the laws of exponents. If you know the laws of exponents, then it will save you a lot of time. So laws of exponents, once again, says that whenever you are adding Scientific notation, your base and your exponent needs to be the same. So I would have made my exponent of 4 to 6. Mr. Beavers, how would you have made that to 6? I would have moved my decimal. I can show you. My decimal's right here. I would have went 1, 2 places back to now say 0.2 times 10 to the 6. See how I got 6, 6. And I would have added from right there. So what I'm telling you guys is this. You didn't even have to do no math with this problem because we knew that whenever we add, our number is getting larger. So there would have been no way for us to get to the 4. Your answer is the first one. 14. It says the United States exported approximately 9 million tons of wheat over an entire year. What is the number of metric tons of wheat written in scientific notation? So I'm going to just do... All right, our decimal have to go after the first number, which is 9. So I'm going to put 9. And since there's no other number but 0, I do not have to put a decimal there. I could just automatically go into saying times 10. And then now I just need to count how many numbers are behind that 9. 1, 2, 3, 4, 5, 6, 7, 8. So I got 9 times 10 to the 8. If I'm not mistaken, that's the third one right there. 15. Anything to the 0 power is 1. So 6 to the 0 is 1. Remember that anything to the 0 power is 1. That's a law of exponents. You need to remember that. By remembering that, you're going to be great. So 15, your answer is 1. 16. It says, Graham's class raised $500 in a coin drive for the school fundraiser. The total for the entire school campus was 5.8 times 10 to the 3. How many times greater was raised by the school compared to Graham's class? Express your answer in scientific notation. Once again, this is division. So I think out of these 16 questions, 6 of your problems were division. If you know how to divide by scientific notation, you're going to be great on this test. So the first thing that I'm going to do is I'm going to write down what the whole entire campus did, which was 5.8 times 10 to the 3rd. And now I'm going to write 500 in scientific notation. So up here, 500. I got to put the decimal after the 5. 5 times 10. How many zeros are there? 2.
Yeah.
All right. So I want to break this up. I got 5 times 8. 5.8 divided by 5 times 10 to the 3rd divided by 10 to the 2nd. And we got 5.8 divided by 5, which is 1.16 times 3 minus 2 is 1. So I got 10 to the 1. So our answer is 1.16 times 10 to the 1. That's your answer. For these problems, there is no answer key. You just need to know how to do it. Moving on. 17. It says Mark studied a group of 50 whales. Each whale weighed approximately 4.8 times 10 to the 5th pounds. Find the total weight of all of the whales. Express your answers in scientific notation. All right. So the first thing that I'm going to do is I'm going to write down my problems. Sorry. All right, so the first thing that I'm going to do is I'm going to write down my numbers. So I got 4.8 times 10 to the 5th. All right, and then I got 50 wells, right? Well, I can rewrite 50 wells in scientific notation as 5 times 10 to the first power. Mr. Beavers, are we adding, subtracting, multiplying, or dividing? All right, the thing is that we want to know that if each well weighs 4.8 times 10 to the 5th, we want to know what's the total weight for all the wells, and we have 50 wells, so I'm going to multiply. All right, I'm going to multiply. So once again, I'm going to break this problem up into two. So I'm going to take 4.8, and I'm going to multiply that by 5. 4.8 times 5, I get 24. All right, and then I'm going to take 10 to the 5th times 10 to the 1st, and my basis stays the same at 10, and then I got to add 5 and 6. 5 plus 1 is 6. So I have 24 times 10 to the 6. Mr. Beavers, is this answer in scientific notation? This answer is not in scientific notation because the decimal must go after the first number. So 24, I need to take the decimal, which is located, I'm going to change the color so you guys can visually see it, which is located right here, and I'm going to move it right here. So if I'm moving back 1, I am moving further away from my number, so it becomes 2.4 times 10 to the 7th. All right, and this is your answer. And the next one, it says the distance from Fresno, California to Glasgow, I don't know, Scotland is 6.566 times 10 to the 5th miles. The distance from Glasgow, Scotland to Tokyo, Japan is 7.393 times 10 to the 5th miles. If you were to travel from Fresno to Scotland and then Tokyo, how many miles would you travel? All right, so what we're doing is we're going from point A, we're going to point B, and then we're going to point C. And we want to know what's the total miles that we travel doing all of that. In order for us to do that, we are going to add. We need to add. So let's take, we got 6.566 times 10 to the 5th plus 7.393 times 10 to the 5th. The rule is if your exponents and your base are the same, then you can add. All right, so 10, same base, and our exponent is 5. So all I got to do now is add my decimal numbers. So I got 6.566 plus 7.393, and I get 13.959 times 10 to the 5th. Is that answer in scientific notation? It is not in scientific notation. The decimal needs to be behind the 1. So since the decimal needs to be behind the 1, I need to move the decimal. I'm going to change the color again from here back. And when I do that, I am now going to add 1. So it becomes 1.3959 times 10 to the 6. And that is your answer. All right. That is your study guide for your test. And good luck.